Hello, friends. Welcome to the ATC Double Cut. My name is Micah Woods, and I am back with another special turf math episode. And I'm here with Jason Haines. And Jason Haines is the golf course superintendent at Cabot Links in Nova Scotia. Welcome to the show again, Jason.
Thanks, Micah. 2 times in 1 week. It doesn't get any better than this.
Well, I'll tell you what. We had that debut episode of the turf math topic, and the response has been overwhelmingly positive. I've got no negative responses yet, and a lot of people have said, well, not a lot of people, a few people have said yes, more of these, please. So I thought, let's do a focused one. That intro one was meant to be rambling. That intro one was meant to cover all kinds of topics. But in this one, let's just focus on something specific. Let's focus on something that you developed, and that is the growth ratio. And I thought, could we talk about the growth ratio? I'm showing on the screen now a blog post that I wrote this spring that basically shows the growth ratio equation. And of course, some people are going to be watching this on YouTube. Other people will be listening to this as a podcast. I'll put a direct link to this particular post in the show notes. But Jason and I are just going to talk about the growth ratio. And I guess could you just explain how you got the idea and then what the growth ratio is in general terms?
Well, it's kind of a hardcore thing to jump right into in the turf math series, but why not? It's probably the most hardcore thing that I've come across as a person who I'm not a PhD. I'm not doing hardcore science. This is it's a tool to help me make better decisions. So from a superintendent standpoint, it's the most heavy duty math, which it's still not that heavy duty, but basically, over 10, 15 years ago, I started, trying to reduce, pesticides and everything else and just grow the grass better, and trying to avoid, these, periods with like out of control growth or then other problems with not enough growth. I started using the growth potential model, which I learned about from you, that Larry and Wendy had developed from Pace Turf. That was a good tool. And then at the same time, I was using that to kind of schedule fertilizer applications. So the growth potential is just a percentage, a number between 0 and 1. And I would use that to, basically tell me how much fertilizer I needed to apply based on the maximum monthly fertilizer I would feel comfortable with. So for me, that was 2 grams per square meter, or about half a pound per 1,000 square feet.
I'll say,
and
I'll interrupt here, Jason, and say, when I do the math, I would come up with 4/10 of a pound.
Okay.
So for me, 2 grams is 4/10 of a pound. So that would be like putting 1/10 of a pound every week, basically. That's what a 2 gram monthly rate would be.
Most turf managers I know would be comfortable with those kind of rates. You're not really pushing growth. It's kind of just a maintenance rate. So, if the growth potential was 50%, you would be applying half that much per week or whatever your interval was, right?
Yep.
So that was great. But the problem with, and that made huge improvements over just having my program where it was like, it's May 1st, apply this, or it's June 1st, apply this. So that all of a sudden I was taking the actual weather conditions into account more than I was before. That was good, but it wasn't that great, because what it failed to take into account, which is ultimately what we're trying to do with fertilizer applications, is we're trying to manipulate growth, right? We add fertilizer to make the grass grow more. We don't add fertilizer to make it grow less, that's for sure. So there were some times where I would be getting mineralization, and the growth potential didn't take that into account.
Right,
didn't take actual growth conditions into account.
that's right. Because the growth potential is just looking at the site-specific temperatures or the normal temperatures for your location or region, but it's not looking at how your grass is actually growing. And then you had
Exactly.
so you had some brilliant insight on this.
Well, I mean, I wouldn't say it was brilliant insight, but I was just putting a bunch of tools that you had kind of taught me, putting them together in a different way. So, then all of a sudden, at the same time I was doing this growth potential for fertilizer, I was measuring uh, clipping yield. And after a few years, I started doing it better and better to the point where it's pretty meaningful now, the way we're doing it. And that data, all of a sudden, after I have over a decade of data, I know exactly how my grass kind of grows. Um, I started, I would apply that growth potential to what I would consider is the most amount of grass I would want to cut in a day. So where I was before applying it to the most amount of fertilizer I would want to apply, now I was applying it to the most amount of grass I want to cut. And that number is something that I calibrated site specific for my course. And generally, the number I had for that is, I think, was 20.5 milliliters per square meter, or 625 milliliters per square meter per month.
Right.
So,
So
but I'm doing it on a day by day basis.
right. So you proposed a monthly number of 625 milliliters per square meter, which would be 62.5 liters per 100 square meters. That would be the monthly maximum. But then when we break that down to a daily amount, then it's a little bit more than 20. It's something like 20.5. I round that down to 20 just to be easy. So I just say that the monthly maximum is 20, and that's what I put in this blog post. So I showed that equation in the blog post. I said this is the growth ratio equation. It's your so what I'm showing now is your actual clipping volume divided by 20 times the growth potential. So it's got two variables and one constant. The constant is the 20, which is the standard amount of clippings per day that you would expect if the growth potential was at a maximum of 1. And so the growth potential is one variable, and the growth potential is calculated based on temperature, and then clipping volume is what you actually measure. And it's a pretty simple equation, and it results in the growth ratio, which is a pretty powerful tool, it turns out, or a pretty useful number to look at.
Yeah, I mean, what you just explained, I'll just kind of explain it a little bit, but with actual numbers. So let's say
Yes,
today the
please.
growth potential is 100%. So perfect growing conditions. We are giving the plant all the water that it needs to grow healthy. So the water is not a restriction in growth. Um, it's a 100% today. That means that the growth ratio will suggest we grow 20.5 milliliters per square meter. Now I go out and I cut my greens, and I find that actually I only cut 10 milliliters per square meter. So we take that 10 and we divide it by the 20, and that gives us 0.5. So the growth ratio today is 50%. So the problem then with this is great. So we're growing at half the speed, and every grass is a little bit different. So when I came up with this, I was growing POA. POA, I found, was not very happy below 80%. You get down to 60%, and you're getting major anthracnose. Dollar spot becomes a problem. Yeah, the traffic wear tolerance, ball marks, all of these things are not good with POA from what I found below 85%. But then we look at somebody who grows pretty nice bent grass, and Chris Tridabaugh, he's shared his information publicly, so I'll bring him up. He's found that bent grass grows pretty happily at 65%. So whatever that growth potential multiplied by that 20 milliliters per square meter per day, he would be his greens would be quite happy at 65% of that number.
Mm-hmm.
And then now today I'm growing pure fine fescue, and I've calibrated that by trial and error to be about 30%. That's where the growth ratio, I find, we're not cutting excessive amounts of grass, so our mowing is minimized. There's very little issues with ball marks or traffic or wear and tear. And we have no disease issues. We haven't used any fungicide this year.
That's
So
that's very good. I want to elaborate on that just a little bit and say that the growth ratio must depend a little bit on the species, because it's reasonable to expect that Poa annua would need to grow at a more rapid rate than something like fine fescue or creeping bentgrass in order to stave off the the anthracnose problems and the various diseases that Poa annua is susceptible to when it's not growing enough. I think also we can think about it being site specific in terms of how much traffic a location gets, because I could imagine a bentgrass course that does 100,000 rounds might need to maintain a growth ratio of like 0.75, and a bentgrass course that does 15,000 rounds might do just fine with a growth ratio of 0.3. So there's that.
yep.
And another thing, Jason, that I think you may agree with is it's how a turfgrass manager likes to manage. Like, some people might be more comfortable with grass that looks a little bit greener, that they have a chance to verticut a little bit more, work a little bit more sand into the canopy. Well, that's not going to work very well if you have a growth ratio of 0.2. But if you like to have grass that's a little bit off color and it's not growing very much, and when you mow the greens, the you don't get hardly any clippings and you never see stripes and that kind of thing, if that's what you're comfortable with the way that you like to manage, then you may be able to get by with a growth ratio of 0.15 or something like that. So I think the value in this is finding what works good for your grass, for your site, and for the way that you like to manage. And now all of a sudden you've got something that is more powerful than we could imagine, because it's incorporating how your grass is actually growing, and it's taking the current weather conditions at your site and the recent weather conditions at your site, and it shows how your grass is growing. So if you got a better than expected growth year or a better than usual growth year, and your grass may be growing more than you are used to, but in terms of the temperature, it's growing normally, and this is gonna account for that. And I just think it's a really cool way to combine the growth and the growth potential.
Yeah, I mean, it's ultimately a tool to try to get consistent results. So whatever results you want to get, but you can get them consistent. So I can grow my grass at 30% growth ratio or 0.3. And depending on the weather, I can adjust my practices to get the growth rate that I need based on the weather. So if it's cool, I'm going to, let stretch the intervals or lower the rates of my fertilizer. If I find that I'm like, so this week, 2 weeks ago, our growth ratio actually spiked up to 40%, which is much higher than I would like. So we obviously we weren't applying any fertilizer to get growth, and then all of a sudden, it starts dropping down to 20%. I'm like, okay, well, the number I want is 30%, so we went out with a fertilizer app.
I've got a question.
And then
I've got a question about the number. Are you looking at this as a trailing average, or are you talking about what it is on a day-to-day basis? You're talking about an average, aren't you?
Yeah. So I mean, so it comes down like, if I calculate it day by day, but I don't mow every day. So if I go out one day and I cut the grass and I get 10 milliliters, and I go out the next day, well, the growth ratio says I should get, whatever the number is, but I'm getting 0 because I didn't cut anything. So what I use is I have 2 trailing, and I use a sum. The numbers are the same. If you use a trailing average or a trailing sum, you still get the same result. It's a comparison between these 2 models, so it doesn't matter, I don't think. So I use a 7-day trailing average or sum and a 30-day trailing average or sum. And that I use the 30-day is kind of my target, and I use the 7-day to steer that target. Um, so it's hard to do it without showing the actual data and how I would make a decision. But I um, I don't really like to have big fluctuations in growth. So a 30-day kind of, it gives you a bit of time. And then you can see if your 7-day is starting to drop below that 30-day, that maybe it's going to start eventually trending downwards. So then that's the tool I can use to keep that 30-day where I want it to. So the 7-day does a little bit of more spiky than the 30-day, which is pretty smooth. So it's we're manipulating growth, and all I can do with fertilizer is suggest to the plant to grow faster. Like that's how I view it. And we don't have any schedule for fertilizer or any rate schedule. We're just basically going out and when we see that the growth ratio is getting below where I'm comfortable at being, then I will boost growth with a bit of fertilizer. And so I use the 7-day to steer the 30, because the 30 is a little it doesn't change quite as drastically.
No,
and that to me is the number that it means something. It's less important to have a 7-day average. That's
right.
Where you want it to be. It's the 30-day.
I understand. So the 7-day is more sensitive, so you can look at it and see that it's pulling down or it's pushing up or something. What you really care about is the long term, how it's growing, the smooth 30-day. But in order to keep the 30-day where you want it, you're kind of feel what's happening with this 7-day. I got it.
Exactly.
Cool. Yep. Now, so you mentioned fertilizer applications. You'll withhold fertilizer if the growth is stable where you want it. You'll just you won't put nitrogen because if you put nitrogen, it's going to grow more, right?
Yes. Yeah, exactly. And I mean, we weren't applying that much fertilizer in the past 2 weeks, and for some reason we got a big spike in growth. It probably had to do with the temperatures and the huge amounts of rain we were getting. But for some reason, there was some mineralization. Something was making the plant grow, so I didn't need to supplement it further because I knew that it was growing faster than I wanted it to. So that's basically it's a really good tool to schedule fertilizer applications to prevent growing it too slow or too fast.
Do you also use it to decide when to mow? I want to ask, basically what I'm getting at is, what type of things can we use growth ratio for? You mentioned fertilizer because we're trying to adjust the growth rate. So basically we're talking about nitrogen. But do you also look at, do we mow tomorrow or do we add on a roll? Do you use growth ratio for that?
No, I mean, to a certain point, but not really. I use basically just the daily clipping yield. So my target yield per mow is 10 milliliters per square meter. So when I go out, I don't want to get less than that. I don't want to get more. And that's basically based on playability, right? So if I'm getting 10 per mow, if it's every 3 days, I can keep my grain speeds pretty consistent with rolls on the days we're not mowing.
Oh, that makes sense.
Mowing is really expensive compared to rolling.
Mm-hmm.
I think it stresses the plant more than a roll, and where like a rolling, reduces disease, I've seen mowing increase disease. So I really like to reduce the amount of mowing, and that's based on how much grass. So I mean, the growth ratio as its own tool, it doesn't do that, but I can use the growth ratio now to predict growth. Based on those two. I have a 7-day, I have a 30-day. We're getting really into the weeds here, but I can use those two ratios, and I'm going to apply it to the growth potential number, and it'll get me pretty close. But for the most part, I don't really need a model to tell me that. I know if I'm getting I'm growing the grass at a consistent rate, and I'm right now, I go out every 2 days and I'm getting the number I want. And if I'm getting a number that's lower, then maybe the next time I'll go 3 days. Or
I
if the number's too high, then I'll go out every single day.
I understand.
Yeah.
Well, you explained that well, and uh, let me try to repeat that back to you the way I understand it. So we're recording this in August in the Northern Hemisphere. That's kind of peak growing season for irrigated turf. And so you're trying to get 10 milliliters per square meter average clipping volume per mow. And that would be if that was every day, that would be a growth ratio of 0.5. But, no, it wouldn't. Because your growth potential is not 1 right now, so it would be a little bit higher than 0.5 on a daily basis. But if it was in October, when the temperatures are much cooler, you could be getting a growth ratio of 1, but actually the amount of clippings you would get you'd be getting like 1 milliliter per square meter. So you'd get such a tiny amount of clippings. And you actually, for the mowing, I understand you want to look at the absolute amount of clippings to try to get 10 milliliters per mow. And if you start looking at growth ratio, that's going to be totally different depending on the season, which it makes perfect sense to me. So that's good.
Mostly for me, growth ratio is, I mean, it's a tool for scheduling fertilizer. It's to get consistent growth rates and plant health. It's also a tool I found. I don't use plant growth regulators at my current course, but we used them quite extensively in the past. And there's, Bill Kreuser's come up with the growing degree day models. Again, these are all theoretical, right? So we're using plant growth regulators to manage growth. We should be measuring growth. That should be our decision maker, right? Is growth, not just some theoretical number. So I would be following the models, which are pretty good, but they're not real. I would be using the models, and I would be essentially stacking my plant growth regulators. And so I would be suppressing growth with each successive application to the point where I couldn't get enough growth out of these greens. Like no amount of fertilizer was getting them really to grow. So again, I would use that again to schedule my PGRs. So I could extend my intervals to a point where I wasn't over suppressing greens, because that's a big problem. A lot of Bill's research has been like he's shown a lot of like problems with over suppression, over regulation of, and so this tool again will prevent that, because you're going to see, oh my God, if my growth ratio that I want is at 80% and I'm dipping down to 60, maybe I should back off on the growth regulators until that trend starts going back up. Because I found myself, I mean, most guys who are using growth regulators have probably found that they've overdone it a little bit. And so this will prevent that as well, because you can tell if you're going too slow. So that to me is another really useful thing for this.
That's right. I was going to ask you about growth regulators, and you anticipated that and answered it already. And Bill has talked about this some in a couple of podcasts this year. I talked with him once. He was on the Talking Greenkeeper with Joe Galati, and he's got some blog posts also on the Greenkeeper blog where he's been talking about the importance of measuring how much the grass is actually growing. And instead of getting on a PGR program that you just follow blindly, look at how the grass is growing and using the PGRs as a tool to achieve the growth rate that you're looking for. And this is where I think the growth ratio is so useful. I mentioned the growth rate that you're looking for. A lot of people ask me that question: how much should my grass grow? Or people get started with this and they're like, how big of a bucket should I get? Because they've never done it before, so they don't know how much the grass should grow. And that's where I think the growth ratio is so helpful, because we can say a growth ratio of 1 or above is probably more than most people are doing. and then you're sharing the number and saying at your location you're getting 0.3. And actually, I can't tell somebody in Raleigh, North Carolina, how much their bent grass should be growing, or somebody in Pinehurst, North Carolina, how much their Bermuda grass should be growing. It it really depends on your site specific weather and how you want to manage. But if we know that people around the world are getting good results at growth ratios that range from 0.3 with your site specific weather, or 0.5 with somebody else's site specific weather, or 0.8 with somebody else's site specific weather, you can now look at your clipping volume, adjust it for your site specific temperatures that you've got, and you can see where you're at. And all of a sudden now you know how much clippings you should be getting. So I think that's really cool. And I think it formalizes, I'm going to change the subject now. Going back to fertilizer, but it formalizes a system in which we can let the grass tell us when to apply nitrogen and how much nitrogen to apply, instead of getting on these scheduled nitrogen applications programs of, a 20th of a pound every week or a 10th of a pound every week, 0.2 or 0.5 grams of nitrogen per square meter every week or every 10 days or whatever. And I did this back in the day when I managed grass. I did it when I was a PhD student, and I look at how I fertilized the grass for my PhD research project, and I look at it. Of course, that was 20 years ago, but I'm like, why did I do it that way? Unfortunately, I think because so many research projects get done of we fertilize a 10th of a pound every week, and then people get taught in seminars and get taught in school that this is like how you manage grass. People just do that unthinkingly without looking at the feedback. And then the feedback being the grass telling you, and then they're like, oh man, I really needed to get in there and give it a spa day and get some sand down and thin out the canopy. It's like, whoa. I mean, I used to think that was normal. Now I don't. Now I'm like, wait a second. Why did you put that nitrogen if it's growing too fast? And I think it's really nice to have the growth ratio to all of a sudden be like, hey, my grass is already growing as fast or faster than I want it to. And the trend is not decreasing. The trend is stable or increasing. I can, with confidence, skip this fertilizer application and apply nothing. And I think it formalizes that. And I feel like there's not very many people in the world that are doing this. They might do that by looking at the grass, but they're not measuring it. So I know you're doing it this way. A few other people are doing it this way. I encourage people to do it this way, but it's not there yet. But I would be surprised if 5 years from now, if it's not kind of a standard way to decide when to put nitrogen again.
I think ultimately everybody kind of does this already, unless you're just going out with the same rate every week, regardless of conditions on the course. So if you are adjusting your fertilizer rates based on what you're seeing, you're kind of doing this. This is a tool just to help me be better at it. Because I'm superintendent, I'm busy, I don't have like massive awareness. I'm not going to spend 20 hours a day out here, like rubbing and whispering my grass and really, I have people out, cutting greens, they're collecting the data. It's all automatic. I've heard every time I share that I've reduced fertilizer, people are like, yeah, we did that back in the 90s. It didn't work. Well, if you're going out with a 10th of a pound every week and that's working for you, and you go out with half that amount every week, it's probably not going to, or it might work for a couple of weeks, right? If your grass is growing too fast, and then all of a sudden you're not going to grow fast enough. So this is a tool that helps you reduce the amount of fertilizer, maybe, but it's going to prevent growing it too slow. It's going to prevent growing it too fast.
Yeah.
So it helps you get it right. And so the next thing that I would like to add is because I've done this twice now, is how do you calibrate this tool? So like for me, at my most recent course, we start collecting the data. We start, putting the weather data in, putting in our clipping yields, figuring out what the growth ratio is. And then I'm just aware of what the growth ratio is. When we started the season, the grass was growing like crazy. Now, I'm not sure if that is from previous years' fertilizer, like late fall applications, or if that's just the way the grass grows here. I'm not sure. Either way, it was growing really fast. I knew it was growing. It was growing fast for what POA would need. So I just watched that line trend down, trend down. Didn't apply any fertilizer, and I went out and I looked on the greens every day. How do they look? How are they handling traffic? Like, these are things that you still need a skilled turf manager to calibrate this tool, and you still need someone to interpret this tool. So I go out and I use my eyes and get down to 30, and I'm like, the greens are looking really nice. They are like, everybody can relate. Anybody who's working on a golf course, you're like, man, everything right now is just perfect. And then it dips down to 20, and then I'm like, it's looking a little scary, a little, maybe we went a little bit too low. And then the cool thing too is you apply some fertilizer, and then that line goes back up. You're like, hey, fertilizer's working. I probably don't have any nutrient deficiencies to worry about. If I apply some nitrogen and the growth ratio goes back up, everything's working the way it should. So I've also had problems where it doesn't work the way it should, right? Like over application of phosphorus.
That's right.
And
at your previous, yeah, when you were at Sunshine Coast, I remember when you first got there, you were putting nitrogen and the grass wasn't growing the way it should, and that's an indication. And it turned out it was low in some other nutrients and phosphorus, right? So
yeah, and it was a weird case because we at a 10 centimeter depth, we still were fine with the MLSN, but we had 40 degrees temperatures. The POA roots went from 10 centimeters to 1 or less, and we were also applying phosphite, which can induce a phosphorus deficiency in soils that were low. So we had lots of phosphorus in the soil, just the POA couldn't get it. And then we applied the phosphite, and it was tanking hard. And we stopped applying phosphite. We applied a little phosphorus. Boom, growth just exploded. So that was another tool I didn't need to spend thousands of dollars on testing. Just with a pretty good amount of experience and knowledge, and this tool helped me fix it. Now, in hindsight, I wish I could have figured that out, a month sooner before we were riddled with anthracnose. But now, with the experience and I know how to use this tool, preventing it. Like, so at my new course, I can, so far, knock on wood, have come in totally green, never been to this province before, never managed fescue greens. We got the growth rates calibrated very quickly the first time, and now we're meeting all of our performance metrics as far as playability is concerned, pretty much every day. So it's, which, I mean, the other people with lots more experience can do that with other tool, but for me, with no experience, to come in and get that right away, I think has been pretty surprising to me and pretty neat.
That is wonderful. Well, thank you, Jason. That is exactly what I wanted to talk about in this second turf math focused ATC double cut, to cover the growth ratio, to explain how it's calculated and what it's used for, and that explanation of how you calibrated it was very good, and thank you for that. And this is something that just makes a lot of sense to me. I've been recommending it, and all you need is growth potential, which you get from temperature, and clipping volume, which you get from putting the clippings into a bucket. And it's pretty simple, but then it turns out to be really useful. So, Jason,
it's an incredibly powerful tool that it costs you whatever a pail costs. And if you have a computer with a spreadsheet and know like some very basic ways of using that, it's not like I have nothing to sell you here. There's not $5,000 tool that you need. It's very basic.
It is very basic, and yet you remember that I didn't quite grasp it myself at the start. So I can understand that it took me a while to understand it, and I'm very familiar with clipping volume, and I'm very familiar with growth potential, and I didn't quite understand the real breakthrough of what it does is adjust your clipping volume for your site specific weather. And it's that simple, but I didn't grasp it at first. It took me quite a while to understand what the breakthrough was. And just how useful and how practical it is. Now I recommend it. I think it's a standard thing to do. And I'm surprised sometimes when people look only at clipping volume and they'll make fertilizer decisions based on clipping volume without adjusting their clipping volume for how you would expect the grass to be growing given the recent weather conditions. Then now it seems like of course you should use the growth ratio instead of clipping volume. And that's where I'm saying I think 5 years from now, a lot more people will be doing it. So if you're listening to this or watching it, don't feel bad if you don't quite grasp it the first time, but see if you can calculate it. And if you can't, let me know. And I will help you with it, and or read some of the posts that Jason's written about it. There's links to it on my blog. Also, there's a growth ratio hashtag on my blog, or a topic, and you can find out more about it and try it. And I think eventually, just by calculating it, you'll start to see what that number means at your site. So, yeah. And then once it clicks, it's going to click really hard and snap into place. You'll be like, I got it. All right, Jason. Well, thanks so much. I appreciate you taking the time out of your busy schedule to have a chat with me about turf math. And we will, when we both have time, let's do this again and talk about some more turf math stuff.
Yeah, thanks for having me again. And I think, like for this is a quite abstract thing. Maybe one day we go through with an actual spreadsheet. I can screen share and we can just like lay it out, and people can step by step watch exactly how it's done on a spreadsheet so that you guys can make your own. Because it really is not that complicated.
Yeah, I would love to do that.
Yeah.
And maybe for you, would that be a good autumn or winter type of thing?
Yeah, I mean, it wouldn't. It honestly would not take that long. I mean, it would be probably a 15-minute video, because it's basically just a screen share with making a spreadsheet. So it could be pretty straightforward. Doesn't need to have any other stuff around it. Just this is how we calculate it.
Well, good. Let's talk about how we can make that happen, maybe sooner rather than later. And maybe that could just be a video that goes direct onto my YouTube channel, that we could record together. Or heck, you could just do that and put it on your YouTube channel if you want. Anyway, we'll talk about that. We won't, yeah, we won't take up any more of everybody's time. Yeah. All right. Well, cool. Thanks, Jason. Thanks everybody for listening. We'll sign off now. For ATC from Trang, Thailand, I'm Micah Woods. Bye-bye.